Okay, so you said the solution is VLAN.
Okay.
The solution is VLAN, right?
Yes.
Okay. Now, the solution is okay. No problem with the solution. Okay. Now see what is saying here in broadcasting, right?
Yes.
So a network hub have single broadcast domain. Okay, single broadcast domain means hub have also same. See, only hub and switch in collision. Collision will hub will have single collision and single broadcast. Okay,
Yes.
switch will have multiple collision but single broadcast. Okay, so if you are talking about broadcast domain, so a network hub will have single broadcast domain. Okay, because why? Because it is totally dumb, you know, it's no memory, no information is stored in the hub. That's why you can say okay, hub is problem. Okay, that's why hub forwards all the information to each and every ports which is connected to it. Okay.
Yes.
Okay, so all the devices connected to hub will receive the same message again and again. Okay, whenever any communication will occur. That's why in hub network your entire communication or network will be very poor, and the bandwidth will be very slow. Why? Because the bandwidth utilization with the unnecessary message will be there, right?
Yes.
Yes. Now now what switch is saying, switch always also have a single broadcast domain, but the major difference between hub and switch is that switch broadcast only once.
Once.
Yes, it is when the destination MAC address is not present in the MAC address table of the switch. So here it's saying that, see, this guy has broadcasted. Okay, okay. So now again, if I'm trying to communicate, it was this one, right? Now see, this
Yes.
PC has generated now ICMP packet, right? No ARP. Now,
Yes.
but when the packet is coming here, okay, see, single, right? No broadcast. Okay.
Make us know.
Yes. Why? Because now switch know about source and destination,
Yes.
and the source and destination MAC address information was already in the,
Mateo.
yes. So MAC address table. That's why, right? That's why they were easily communicating, right? Okay.
Yes.
Now let's move this. Okay. But when it will broadcast, when there is no MAC information in the destination packet, right?
Yes.
Okay, so if there is information in the destination packet, it will unicast.
Yes.
Okay, now switch create MAC address table on the behalf of source MAC address. Remember I told you about this one, that switch will create MAC address table only when switch will receive message by computer. So if you'll come
Yes.
here, right, see, this switch is generating MAC address table, but how he is generating? See, this PC has sent some data to this switch. So when this switch has received the data from PC1, then he will create MAC
Mat
entry for that
Mateo.
computer. When this PC will reply, at that time switch will generate MAC table for him, right?
Okay.
Okay, see, this is 101 class. Okay, so if you have any doubt, question, you can ask. It's not that,
Yes. Yes.
yeah, it's a batch, then you are feeling shy to ask.
Yeah. No. No.
Okay, now see, now here I have asked one question, that okay, if we want to break the broadcast domain, right? See,
Yes.
to breaking collision domain, we in hub we came with switch, right?
Yes.
Okay, now here to breaking broadcast
Broadcast
domain,
domain.
okay, router came in the place. Okay, now here I forget to tell you something. Here you can say that, okay, sir, this PC, this switch is broadcasting. Okay, this switch is broadcasting only because uh, the they are using same network, right? You see all PCs have same network, right? That's why
Yes,
switch is
yes,
broadcasting. But it's not like that. See, if here, if you'll come here, right, if you'll come here, see all the computers are in a different network, right? Here also and here, see this. But here this network wants to communicate to same network computer. Okay, now see, you can see here it is broadcasting, right? Here, see,
yes,
in the same switch. But see,
yeah, same thing again.
again, here this switch do not know about, see, do switch know that, okay, this packet belongs to 10 network and this PC belongs to 20 network?
No,
Switch don't know about layer 3 address.
no,
Yes, that's why it is broadcasting. And layer 2 MAC address, do layer 2 MAC address have classes?
no.
No classes. That's why it's broadcasting, because switch cannot differentiate networks. So it doesn't
Yes,
mean that if I'm in a different network, switch behavior will be something different, and if I'm in a same network, switch behavior will be different. Okay.
okay.
Hmm. Now, so there are some other options you can see here, that breaking a broadcast domain is like, see here, if I'm using and if I'm communicating here. Okay, now see, next packet will come here, packet came, and now packet went to router, but router will not forward to the another network, right?
Yeah, it blocks.
Yes. So yes, you said correct that, okay, we have VLAN concept, and say we have another concept which is breaking
Routers.
the broadcast domain concept with the help of router. Now why VLAN
Okay.
is not correct? Because you are a
So
CCNP guy. I can say no, 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 VLAN it's okay, but VLAN,
if all of them are in the same VLAN, it will do the same again.
no. But you said here, I have written somewhere that you said VLAN, right? Okay,
Yes.
but now,
Yeah.
okay, I can understand that. Okay, you said correct VLAN, but if I'm talking about this network, okay,
Okay.
this is 10 network and this is 20 network, right?
Yes.
Okay, now, but for other communication, maybe this 10 wants to communicate to this computer. At that
Yes.
time, do VLAN will work?
No.
No. So VLAN is there, but at that time, if these type of communication you need to create in your organization, that, okay, I want to, I want to break, I want to, what you can say, I want to mm, stop, you can say, not stop, break, you can say, to reduce the broadcast domain, right?
Okay.
Okay, when I want to reduce the broadcast domain, I can use VLAN. Okay, but maybe if another, maybe if computer wants to communicate from one network to another network, at that time you need to create inter VLAN
Integral
routing. So for inter VLAN routing, what you need?
router.
No,
Layer 3.
layer 3 device, right?
Yes. Yes.
Yes. So
With
you need
SAP
layer 3
interface.
device to break the, you need VLAN also, but
Yes.
as per CCNP guy, you need VLAN, okay, plus layer 3 device.
Yes.
Yes. Okay, that's why router we are talking here. So router uh, are the best kind of devices in this kind of breaking the large broadcast domain. The reason
Okay.
is the router will have multiple broadcast domain. Why? See, router, why is saying that router will have multiple broadcast domain? Because if router has two ports, so there will be two broadcast domain. Okay,
Yes.
now Now each port of the router use separate broadcast domain. We know this one. So if there are three interface used in the router, okay, for three different networks, so there will be three broadcast domain, right?
Wait, yes.
Yes. And by default, router will never forward the traffic of one broadcast domain to another
Another
broadcast
one.
domain, right? That's why router reduce the broadcasting problem in your network, right? And when router will forward the data of one broadcast to another broadcast, when they have routing.
Routing
Yes,
protocol.
it's not that router will directly forward the data without routing. Okay. Now, so here are some, some information that, okay, how many devices I can connect to one network, okay, because I want to reduce the broadcasting. So the recommended PCs, or recommended, what you can say, that you can connect only like 250, not even 256. I'll remove it. Okay, it's
Okay.
250. Okay, 250 devices in a single
Single
broadcast
broadcast.
domain. Okay, this is recommended. Okay, but it's not written. See, recommendation is what I am recommending you, but you will not follow. Okay,
So
I'm
when you
saying
go
you.
higher, the more.
Yes, so if I'm telling you, so 250 means you can use class C address, right? Or slash
Okay.
24 subnet, right?
Yes, yes.
But maybe if you use slash, like slash 16 subnet, so you can have 65,000, right? You can use
Yes.
slash 23, so you can have how many computers in your network? 512, right?
Yes.
Okay, so it's it's recommendation, right? But recommendation is that you should follow it.
Yeah.
Okay, layer 2 forwarding concept. Now, how layer 2 forwarding concepts is working? So he's saying that a layer 2 switch does not rewrite frames like router does at every hop. Okay, see, if I'm talking about router, okay, so if any data is passing from router, right, router rewrite the information on the packet. Okay,
Okay.
so this is a little bit technical, okay, but slowly you will understand when you will read the packet of the. Okay, so let's,
Okay.
did I configure routing here? No, I have not. uh, okay, so see, if if you will create here routing information, okay, so when the packet will come here, so router will put his own layer 3 information, right? See,
Yes.
right now, when the data is coming to switch is not writing anything that, okay, this packet is related. Switch do not interfere anything on the packet. Okay, but router interfere. Why? Because maybe that packet came to this router with the help of reap, or maybe with the help of ethernet, and then he will forward that packet with the help of reap, or maybe with the help of eigrp, right?
Yes. But
Yes.
here you have only one router, so there's no need for you to. There's no need for us to configure a routing protocol, right?
No need to configure. So
Yep.
here what you have to do, you have to come to the
Mm.
computers and you have to inform about the default gateway.
Yes. Yep.
10.0.0.10, I think I'm using this one, 10.
Okay.
Okay, let me come to real time, delete this. 20.0.0.10. Okay, now let's try sending the packet from here to here, and then we'll read out the packets. Packet came to switch. Switch has forwarded to router. Now router
Yeah.
has forwarded to this switch.
Mhm.
This switch is now everything is working unicast, right?
Yes.
Now let me come back here. Now let's read this. Uh, when the packet came here, now let's read this packet information. Still it is layer 2. Okay, let's see when the packet is coming back. Why it's not coming? Okay, now let's. Why is it dropping? Did I configure the IP address on the interface? Enable show IP interface brief. Its information is fast Ethernet 0 by 0, 0 by 1, 20.10. Why packet is dropping? ICMP process. Saying failed. Okay, no problem. We'll check. I'll explain to
Okay.
you. Okay. So let's understand the concept. Okay.
Okay.
Okay. Okay. So what he's saying that layer 2 switch do not rewrite the frames like router does. Okay. And why router rewrite the frames? Because router forwards the information on the behalf of different routing protocols, right?
Okay.
Now switches store the information and forward the frames, okay, with the help of MAC address, right? And MAC address is built by the flash memory, and flash memory is also known as ASCI, means application specific integrated circuit is there. Okay, and that flash memory store the information. Okay, and with the help of that information on based on those information, it has been forwarded, okay, to the destination, and it take the decisions, right? Now it
Okay.
use MAC table for forwarding, to take forwarding decisions, right? And it forwards the data which has been received from source to destination. Now, how does a switch learn MAC address? You already know that the switch is layer 2 device which is used to connect multiple devices in our LAN segment,
Done.
right? Now, but by default switch broadcast and multicast both at every port except the originated port, means, right? Multicast and broadcast, okay.
Yes.
Switch do multicasting also, okay.
Okay.
And in which condition switch do multicasting? Okay, switch do multicasting also, broadcasting also, and unicasting also. We'll see that one.
Okay.
A switch has some intelligence, okay, operated on layer 2 with the help of OSI model, okay. And which intelligence switch use? your MAC table and ARP to find the information, and then it forwards the right. Okay, so what he's saying that as how switches learn the MAC address. So switch learn the MAC address with the help of ARP, and it stored the informations right in his MAC table, right?
Marked.
Yes. Now, so to understand this, to this all scenario of communication, that okay, how the switch, how PC is generating. Okay, so this is the case study. You learn this. Okay, you just go it. Okay, not learned it. See, it's written like, let's say we have three devices which are connected with switch with using its three port. When PC0 wants to communicate with PC2, first it will create a packet which is known as layer 3 PDU, because switch will say that okay, I want to communicate to so and so with the help of layer 3 address, not layer 2. Okay, layer PC will say that I want to communicate with layer 3, not with layer 2, right?
Yeah.
It will set the IP address, okay, in the packet header, and it will forward. Now, so how it
Yeah.
will write? It will write that okay, source IP address PC0 IP address, right?
Yes.
Destination IP address PC2 IP address, right? Now,
Yes.
when the packet will be forwarded to the lower layer, like layer 2 data link layer, it will create a frame of layer 2 PDU, okay, protocol data unit, and
Okay.
will need the source and destination MAC address in the packet, right? Now, source
Okay.
MAC address, yes, he know the source MAC address of PC0, right? But
Yes.
destination MAC address,
And
I don't know. That's why now it has the source MAC address, okay, its own MAC address, but no destination MAC address. Destination MAC address is missing. Okay. Now, if you will check ARP minus A on the computer, and you will see that output means there is no ARP table, right?
yeah.
Okay. So to resolve this MAC address of the destination, okay, here comes the concept of address resolution protocol.
Protocol.
Now, what is address resolution protocol? You know that address resolution protocol is a process to find the MAC address of the destination device. Now,
Yes.
ICMP packet, see, did you created our packet, or our packet has been created automatically?
Our packet has been created automatically.
Yes. So you created ICMP. So ICMP
Yes.
is on hold now, right?
Okay.
Yes. And then they generated ARP. Why they generated
Yeah.
ARP? Because they do not have destination information, right?
Not
Destination MAC
addressing.
information. So this ARP request will then hand over it request
Just to
to layer 2, which is known as ARPANET or ARPA protocol. Okay. Then ARPA protocol will run over the physical links to the next device to find the MAC address. Okay.
Okay.
So what we have seen in our case, right? Now,
Yes.
okay. So see this book, what you are getting here, this notes is written by me. Okay,
Okay.
it's not
Okay.
downloaded or something, it's written by me,
Yeah, I
that's why.
see.
Yes.
Sometimes people used to download it.
No, it's
Uh,
it's created by me, that's why each and
okay.
everything will match. Okay.
Yep. Yep.
Now,
So can I have it, or you do not send it to me yet?
no, of course I will give you, I'll give you lesson by lesson, because I'm creating.
Okay. Okay.
Okay,
Okay.
so like, today we will complete our switching information, then I will forward when I will in next class, when we will work on VLAN, then I will forward the VLAN. Okay.
Okay. Okay.
Okay, so here source MAC address was this, but destination MAC address was missing. Okay.
Yes.
Then ARP will give this information to ARPA. Okay. And ARPA net will create a frame. Okay, which frame? This frame what we are talking here, simulation, this frame, this frame, who will create this frame? Okay, ARPANET used to create this frame, this payload, version, ISL, this TTL, these all things.
Okay.
Okay, and then ARPANET will find the information, and then ARPA will give to IP. Okay.
Yes.
Okay, so these things are there, but slowly we'll work on this. Okay.
Cool.
Okay, and then ARPA will have the information, same source MAC information, target is missing. Then ARPA will say that okay, let's put target as a broadcasting MAC address. Okay, so this is all same thing what we have talked. Okay, it will
Yeah.
forward to PC0 like this. Okay, now here are some information. Now some verification that okay, so interface status. Now in the, if I will write like this, what I will get. So if I'm coming here, let's come to our switching. So MAC address table, see no information, right? Now let's have
Yes.
the information first. Okay, and now if we'll come to this switch, come here, enable so MAC address table. Yes, now MAC information is there. Okay.
Yes.
Okay, so what we are coming to know here, so interface status.
Yeah.
I, and let's see that whether our packet tracer will support this, because see I'm using this packet tracer today only. Why? Because
Okay.
to see the packet movement. Okay, but we will be using our GNS.
Cool.
So type here so interface status. Now see,
Okay.
so when you will type this, see what is saying that
Mm.
connected,
Yeah. That's
connected, and duplex is auto. Okay, speed. So see here,
okay.
100 base TX, 100 base TX means 100 Mbps base band. TX means okay, it's twisted pair fast Ethernet.
Yes. They used to write it even on the cable that they used to buy it.
No, which table?
No, I'm talking about the cable,
Yes,
UTP
yes, they,
cable.
yeah, on the cable, yes.
Mm.
Okay, and they belongs to which VLAN. Okay, what is the duplexing mode? Okay, speed is auto or something like that. But like suppose if you'll say no, I want to change the speed of this interface. See you. Okay, interface fast 0 by 0, right?
Yes.
0 by 1. Is it like okay? See, so control C, conf T, 0 by 1. Okay, speed I will give 10. Okay, and then see if you will give speed 10, then see speed is what,
Yes.
10
Then.
Mbps now.
Yes.
Okay, so even if you will, you can, if you want, you can change the speed of the interface.
Yeah.
Okay, now if you want to see, suppose if I'm coming here, you see the MAC address, when what we have learned here. So MAC address, okay, see the MAC address is in dynamic mode, right? So if you want, you can
Yes.
see here, so MAC address table. Okay, see here, static or dynamic. So if why multiple options we have here. Okay, okay, see here, why? Because see right now we are using only two switch, but if you'll go to the organizations, right, you can have, you know, multiple switches, right? Are you
Yes.
understanding?
Yeah.
So when you have multiple switches in your organization and you wanted to have the information of all those computers who is connected to your switch, okay, so at that time you need to have the informations, right? So if you learn that, okay, how many computers are connected to my, why is always, okay, it's a different network, sorry, okay, let's come to this one, yeah, same network, okay, let's try to communicate from here to here, from here to here. I'm just generating the MAC table or something like that.
Yes.
Okay. So now if I'm coming on to this computer, to this, sorry, to this switch. So if I'm coming here and typing, so MAC address table. Okay. So can you see here? See here, understand it. Okay. This MAC address is 4, right? So
Yes.
here also this MAC address is 4 4. This MAC address is also 4. Are you understanding?
Yeah, I can see
Means
it.
switch is learning multiple MAC address on this fast Ethernet 0 by 4, right? Means multiple MAC address means MAC address of this computer, MAC address of this
Yes.
computer, okay,
I mean,
MAC
for
address of this
power.
computer, yes, okay. So these informations, so how I will come to know, see if you will type like this, so MAC address table dynamic and interface like this, I think do it will support like
I
this.
don't think so.
Let's
Did,
try.
yeah. It seems like last time I tried, but
So MAC address table dynamic,
dynamic.
no, it's not supporting, okay, but your
Yeah.
GNS3 will support, okay,
Yep.
yes.
Yeah.
So when you will type this command that, okay, I want to know that from this interface, means from which interface, from this interface my switch is receiving how many MAC address, so you can run this command,
Okay.
okay.
Try
Even
this one.
if you want to check the MAC address, okay, that, okay, this MAC address is connected to which port, okay, you can run like this also, okay. So
Okay.
it's part of practicing, and remember I told you about this one that 300 seconds is given there for your
From that
yeah, in your
switch
switch
keep
Mac, what you can say, the aging time of switching, right?
keeping the
Yeah,
market.
aging time, you can increase the aging time also, you can, if you come
Okay.
here, conf t, like how to increase the aging time, like okay, let me check, we'll forget that.
We're trying to increase the aging time.
Yeah, I'm just checking, just I
Okay.
forget command, so I'm just checking that command. Some Cisco command, if you forget, then
Yes.
Mac table aging time, that is, just one second. Okay, you can write here. MAC address table. No, it's not working. But no problem. If it is not working, we have
Yeah, DNS free.
yes switch. Let's take one switch. Start and they take console. Okay. See, so MAC address table question mark. See, you have multiple options, right? Now if you'll say
Yeah.
dynamic, then after dynamic you have interface what, then you put question. Okay, so interface ethernet 0 by 0, so they will give you that information. Remember the earlier one what we were talking. Now
Yes.
we are talking about aging time. So you say here,
Yes.
so MAC address. Okay, now let's change something like that. So MAC address, MAC address table, aging time. See here, aging time, and now you can give whatever aging time you want to give, right? Okay,
Okay.
by default it is 300 seconds, but you can increase up to
Okay.
what we can say, is it 1 million or what?
Cool. Yeah. Okay. Let me see. Yeah, it's 1 million.
Yes, so you can increase, but see, you will not find these number in the lower series of, okay, by lower series of switches. Okay, by default it is 300 seconds. Okay,
Okay.
but you can increase that. Command is here.
Okay.
Okay, now if you want, you can, if some information is there, with the help of this command you can clear the MAC address table. Okay, clear MAC address table
Yes.
dynamic. So I think this command will work here. Okay, clear MAC address table dynamic. Yes, this is working. And then if you will see nothing else there, right? Okay,
Yes.
so this you can remove. Okay, now static MAC address. Okay, so
Yeah.
do we need to see by default what MAC address we have seen here? So those all MAC addresses was dynamic, right? Okay,
Yes.
but dynamic can be uh, removed after 300 seconds, right? But
Okay.
in which condition you need a static MAC address? Okay, so a static MAC address you can fit in your switch for some kind of servers. If you have a special servers in your organization, you don't want
Okay.
for him to be broadcasted or something like that. So normally you can put a static entry for him. Okay, maybe
Mm.
your boss is using some computer, so for boss also you want to add some kind of a static entry, right?
Okay.
And static entry is important, okay, to stop these kinds of attacks or vulnerabilities in your networks. Okay, because see,
Because
MAC
it's
flooding,
gonna affect.
yes, you know about MAC flooding. MAC flooding
Yep.
is one kind of MAC. Okay, it means like hacker comes to your network and they start flooding the MAC address in your network, right? And then
Yes.
your switch MAC address will be, the MAC address entry will full. Okay,
Yes.
and then when your MAC address entry will full, then your switch will start behaving like hub, because switch
Okay.
MAC address table storing capacity has some limitations. And limitation is, I'll show you. Limitation is, I think it is yeah, limitation is this one.
Okay.
Okay,
4 5. Yep.
yes. Okay, So these things we will work in, like in GNS, then we will work more on this. Okay. Okay,
Okay,
that
yes,
okay,
that's
how to put a static. So it's very simple. MAC address table static, MAC address of the server, and you want to put this, that um, computers or
develop.
that server in which VLAN, and the interface on which it is connected. Okay.
Okay,
And if you want to check, so when you will write like this, okay, maybe if the previous engineer has added that port, but now when I came to the organization and I want to know that, okay, this MAC address is connected in which VLAN or in which port, like that. Okay.
okay,
Now layer 2, switching design and problems. I told you Ethernet this Ethernet network use to have scalability limitation based on collision domain. Okay. So that's why we have removed this hub. Okay. And now we
yes,
came with switch. So layer 2 switch, segments of collision domains has been divided by per port. Okay. And
yeah,
layer 2 switch still have scalability issue based on its total host in the networks. Okay.
yes.
Because of broadcast domain, that's why we came with router. Now what is
Router.
saying that, okay, if you have a very large switching network, maybe you have 10,000 people working in your organization, right? Okay, so
Yes,
inside in your organization you cannot have router and router, right?
yeah,
I understand. Router is always the edge part. So inside in your
yeah,
organization you can create VLAN, or we can use SVI. Remember, layer 3
yes,
switch.
yeah.
Yeah, switch virtual interface, right?
Like connecting the VLAN to the
Yes,
port.
yes. Okay. Now, CAM table limitation. I told you the MAC table has the storing limitation is 45,000. But if it is
Yes,
full, then what will happen? Then the attack can happen in your network. Okay.
yeah,
That's why I will make some kind of design in my network that my switch cannot store the MAC address more than 45,000. Why?
okay.
Because I will keep some router, or maybe I will create VLAN in something like that in my organization, right?
To avoid this kind of problem.
Yes. Okay. Broadcast domain limitation. Okay. So see, broadcast domain limitation is everything is depending on your network design. That, okay, I will do some kind of VLAN. Okay. So VLAN is used to what? To stop the broadcast domain, right? To reduce the
Yes,
broadcast domain, right? Okay.
yes,
So see here, limiting host per VLANs to limit the broadcast domain size.
yes.
Okay. And then I will create some kind of securities in my layer 2 securities to stop the attacks of my network.
Okay,
Okay. And I will use the when I will create VLAN, then I will use /24 IP subnets. Means I will make sure that, okay, only 250 or 200 55 computers or 254 computers will be there in my network.
yeah.
Okay.
Mm,
Okay, then in our next class we will be using from what is switch, then the switch information, and then VLAN. Okay.
cool. Okay.
See, these are some basic information we need to know. Even
Yes,
we
like
when we are, yes.